The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to day 3 of our 4-part webinar series. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. Please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handout section of the GoToWebinar panel, please note also that a PDF copy of today's presentation is available for reference. With that, we will go ahead and turn things over to Ron Eck. Good morning, Ron.
Thank you, Mike. Good morning, everyone. Welcome back for day 3 of Bicycles and Pedestrians. Before we get into the agenda that I'd planned for today, I did want to address one question I believe Kyle asked last time on Thursday that I said I would look into, and he inquired about using RRFBs and pedestrian hybrid beacons on uncontrolled approaches to unsignalized intersections, and he asked what is the recommendation on pavement markings for the far side approach. And here's a couple of examples that I was able to find. This is from the AASHTO Bike Guide, the recent late 2024, the new AASHTO Bicycle Guide. And I apologize, I turned the figure over to is the uncontrolled approach. And notice the pedestrian hybrid beacon is located here where my cursor is. And so notice there's a stop line here, and of course a stop line on this approach. And in fact, the MUTCD says a stop line shall be installed for each approach to the crosswalk. And then in terms of RRFB, that uncontrolled marked crosswalks, this is figure 4L-1 from the Manual on Uniform Traffic Control Devices. Notice they show marked crosswalks at across all 4 approaches, and you can see the use of the RRFBs. So hopefully that's helpful. This is our agenda for today, the topics that I hope to talk about. You see a variety of different topics today. We'll look briefly at road diets, pedestrians and bikes at interchanges, bus stops, talk about maintaining roads and streets for all users, and then we'll begin our discussion of bicycle facility types, and we'll finish that up on Thursday. Road diets, or some people call them road reconfiguration. This is revising, the lane use or widths to basically result in one travel lane per direction, kind of the minimum practical width, with the goal of reducing the vehicular cross-section to provide some additional space for maybe left turn lanes, for on-street parking, for wider sidewalks, for pedestrian refuge islands, and those kinds of enhancements. This shows kind of the general schematic or concept drawing, if you will, for a road diet or road reconfiguration. Notice beforehand we have 2 lanes per direction, undivided roadway, so there's just a solid double yellow center line in the middle of the roadway. And then after, you see that we now have 1 lane in each direction. In this case, there is a 2-way left turn lane in the center, and you see there's depicted here wide shoulders, but this could take a variety of different approaches. That could be on-street parking. It could be a widened sidewalk. It could be bicycle lanes there. So that's why I say this is strictly a concept drawing. The individual details would depend on the specific context. Last year I was at a session, someone said that they've stopped calling these road diets, that he preferred the term road buffet because there were so many different alternatives or options one could do to enhance bicycling and walking. And I kind of like that term. Applications, high likelihood of acceptability for nearly all road functional classes. Can be used in urban or suburban or even rural settings, appropriate for most common urban speed limits. You can apply these at or near intersections or along road segments, and they are appropriate along bus routes. Some of the pedestrian and bicycle benefits of road diets, as I've said, they reallocate space from travel lanes that previously were travel lanes, which are now converted to bicycle lanes or sidewalks. Generally, motor vehicle traffic speeds are reduced, which should lead to fewer crashes and certainly less severe crashes. And the 3-lane cross section, 1 lane in each direction, makes crossing the roadway easier for pedestrians, shorter crossing distances, less exposure time to vehicular traffic. Some of the design issues include the transitions. You do need to transition from the adjacent or adjoining roadway sections to the road diet cross section and also through intersections. And another thing to think about is the amount of traffic. Remember, we're reducing the number of available lanes, and so this impacts the demand that can be accommodated. A typical acceptable threshold is about 1,000 vehicles per direction during the peak hour. We have a roadway here in Morgantown. It's a 5-lane cross-section kind of entry to the West Virginia University Hospital Medical Complex, and it's probably for decades people have been suggesting, this would be nice to do a road diet here. We could reduce traffic to 1 lane in each direction. We could put bicycle lanes on the outside, and in the center, instead of a turn lane, we could put an attractive median to make this a nice gateway to the university campus. And that sounds well and good, but the issue is that this particular roadway accommodates or carries right now about 35,000 vehicles per day. And that, to me, would not work if we had 1 lane per direction. So you do have to look at your volumes, and the road diets may not work for higher volume roadways or arterials. Potential impacts, I mentioned that reducing the through lanes tends to reduce speed. You can also narrow the lanes to reduce speeds. Pedestrian crossings are improved, usually made easier. And you can improve bike accessibility if the travel lanes can be used for shoulders or bike lanes instead. Here's an example. I believe this is in Maryland, a suburban road diet example. You can see the before situation is on the left. Notice, looks like 4 lanes, 2 in each direction with a double yellow center line in the middle of the roadway. And then afterwards, and this shows the transition section as well, but afterwards, notice it's 1 lane in each direction. We have a left turn lane there in the center, and then a bicycle lane, probably on both sides, but certainly on the right side, you can see the bicycle lane. And notice the before situation, not sure when this was taken, but notice we don't really see much, if any, of the way of vehicular traffic. So this looks like it would be suitable to reduce to 1 lane per direction and enjoy the benefits of the road diet. Here's an urban example. This is from Seattle, Washington. It is the same arterial. It's not the same section, obviously. They're 2 different sections, but it's of the same arterial. And notice, again, it was 2 lanes in each direction, just a double yellow center line beforehand. And now they've reduced it to 1 lane per direction. You can see the 2-way left turn lane in the center, also on-street parking, at least on one side, and then a bicycle lane as well. Another situation that some agencies may face, not everybody, of course, but some agencies may face, is accommodating pedestrians and bicycles at interchanges. And you see running kind of east to west, left to right across the image here is a limited access roadway, a freeway or interstate type highway. And then the north-south roadway is kind of the local road or street. And notice at this interchange, I've kind of highlighted or identified the conflict scenarios where you have vehicles either heading forward to enter the freeway or vehicles that are leaving the freeway and are merging or turning onto the local roads and streets. And of course, these are conflict areas for vehicles too, vehicle-to-vehicle conflicts. But what I'm concerned about here would be the vehicle-pedestrian or vehicle-bicycle conflicts that occur. And one of the things that happens on these roadways, as you can appreciate, is, for example, let's take this movement here from the left, let's say eastbound, and a vehicle's exiting on the ramp here and maybe merging with the local road and street, or maybe turning left. But let's take the merge situation. Let's say drivers here have been on this limited access highway for some period of time, and so they're kind of conditioned to high-speed roadways, no stop or yield conditions, that sort of thing. And so when they get onto the ramp here and start connecting with the local road and street system, the question is, how can we, through design and traffic control, how can we help them be better behaved in terms of yielding to or stopping for pedestrians or bicyclists? So that's what I'd like to spend a few minutes talking about. And here are some best practices in that regard. One is to try to minimize the number of conflict points between vehicles, bicycles, and pedestrians. Design the ramp geometries for slower vehicle speeds until they're past the crosswalk. Locate the crosswalk at the location with the best visibility and before the point where vehicles begin to accelerate to merge with the traffic stream on the local road or street. Design crosswalks to be as short as possible. We've been talking about that in other regards, without deviating excessively from pedestrian desire lines. We also talked about that, I believe, on day one, that pedestrians are least energy people. They'll try to take the shortest path as much as possible. So we don't want the pedestrian path to deviate too much from their expected desire lines. For bicycles, define a weaving zone, we'll call it, where the bicyclist can decide when to merge safely across vehicle lanes. Orient on and off ramps at right angles to the arterial roadway to encourage slower speeds. Use color treatments for bike lanes to highlight merges and transitions. And we'll talk about color treatments on Thursday in our last session, but this would be a place where, excuse me, those color treatments would probably be appropriate. And then make sure you have high visibility striping and directional curb ramps for all crosswalks, and provide advanced limit lines at multi-lane crosswalks. These would all be best practices for locations where interchange ramps intersect local roads and streets.
Hey, Ron.
And here's sort of an, yes, Mike.
Sorry to interrupt. We do have our first 2 questions, and I've copied those into the chat.
Okay. Eva says, when placing a bike lane next to a parking lane, how can the potential for car door openings striking cyclists be minimized? Great question, Eva, and can I delay that until Thursday? We will talk about that. That's known as dooring, and we'll talk Thursday about some techniques to deal with that. And if I don't answer your questions, then please speak to me again or let me know. Anthony says, I see road diets frequently use the removed vehicle space to install bike lanes. Are there examples that use this space to then make space for an SUP instead? SUP is significantly lower in stress than bike lanes. I'm not sure why SUP are not more popular with road diets. Good question. I'm trying to think. I'm sure there are some examples, but I'm not sure I'm thinking of any off the top of my head. But we'll make a note of that, and I'll see if I can maybe find any, or if anybody that's with us in the session has examples that they want to identify. We'd appreciate that. But yeah, but I'll make a note of that. Good questions. Here's an exit ramp example. Exit ramp from a limited access highway. So that would be from the upper right here toward the lower left. So this, for example, this white vehicle that's in this sketch, it would have been traveling on a high-speed limited access highway, and now it's leaving that facility and coming onto the local street or road system. And notice here, but the agency has a bike lane here and also a sidewalk, conventional sidewalk, and they're showing the crossing point here. I'm not sure why they're not showing that a marked crosswalk. I think that would be appropriate there. And then, so you can see the pedestrians and the bicyclists then are now on up top here on the other side of that ramp. And notice, as I said earlier, hopefully this crossing is before the area where the vehicles start to accelerate to merge with the local street. And just from the sketch, it appears that that is the case. And you can see the signing here as well as the angle of intersection. Obviously not close to 90, but 65 to 75, I think, is probably appropriate. I wouldn't want to make it much flatter than that angle. What about bus stops? Obviously, that's a critical connection point between modes. Pedestrians, bicyclists, and transferring passengers need to access bus stops. They should be comfortable, safe, convenient, and designed for the local context. So that may differ from place to place. In terms of network considerations, there needs to be an accessible route, sidewalk, a path, or a shoulder to connect to the bus stop. And this should be located where there's existing or future demand, for example, office buildings or schools or medical centers, residential complexes, destinations of that sort that generate demand. And at intersections and mid-block, consider if a marked crosswalk and or additional crossing treatments might be necessary. What's wrong with this picture? Hopefully it's clear. Notice this is a marked bus stop in this jurisdiction, but notice the sidewalk along the roadway ends probably at a property line back here, so there is no accessible route to the bus stop itself. So, and just this bare earth or grass is not considered an accessible surface. So hopefully this is on a transition plan identified as a barrier to accessibility and hopefully scheduled for remediation so that there will be an accessible route to that bus stop. In terms of if there's a structure or shelter used at the bus stop, then the clear zone concept may come into play. And here we're talking about the AASHTO Roadside Design Guide. That's kind of a good starting place, I guess, but you probably need to use engineering judgment and consider the local context when you're determining clear zone distance. And the location of and access to or from a bus stop may be considered as an appropriate reason to reduce the clear zone if needed. And here's what can happen, with an obstacle of any sort in the clear zone. But I'd look at the crash history of a particular road section when you're setting clear zone widths or locating a bus stop, and think about on-road treatments to help keep drivers on the road. Things like pavement markings, rumble strips, signage, delineation, when you do have reduced clear zone widths, like there maybe was in this situation. Bus stop placement should be as close to the travelway as possible once clear zones are considered. And at intersections, bus stops can be placed far side or near side. Generally, probably transit agency for far stops where traffic flow is heavy, where there's sight distance concerns, and where buses turn left. Near side stops may be appropriate where the traffic flow is lower or where transit riders can more easily transfer without crossing the street. In terms of the design of the stop itself, there needs to be a minimum of 8-foot by 5-foot boarding and a lighting area free of obstructions, and that's required for accessibility. There should be at least a 10-foot wide that's measured perpendicular from the street, if possible, and long enough to accommodate the bus stop elements, the boarding and a lighting area, the shelter, and so forth. In rural areas, vertical curbs should not be used at bus stops, again, for accessibility reasons. So here we see an urban bus stop, and notice kind of highlighted in the dashed blue line down here in the lower center, this would be the boarding and a lighting area. Of course, we see the shelter, which is not a required element of the bus stop, but in this case, this stop does have the shelter and maybe a bench underneath the shelter. How about this picture? This is a marked bus stop in a municipality, but notice the mechanism this particular bus uses to make it accessible is the driver lowers a ramp for individuals with mobility impairments to use. But notice when the ramp is lowered, because of the width of the sidewalk, there's insufficient space here for a wheelchair to turn on or off of this particular ramp. And so that's an issue. That's a barrier to accessibility. Fortunately, in this case, probably about 50 feet to the lower left, the sidewalk that you see here widens to about 20 feet wide. And so what the transit agency was able to do was just shift the bus stop probably 50, 75 feet down the street where they could make an accessible stop. But that's something to consider in developing transit stops, is make sure the stop is accessible depending on the mechanism the bus uses for accessibility. I mentioned briefly some of the elements of a bus stop, the shelters, again, those are not required, but if you have them, then they need to comply with the ADA requirements. Sometimes agencies may have advertising, kind of wrapped around the say the windows of the shelter, if you will, maybe help them offset costs, but also need to keep in mind that those can block vehicular and pedestrian sight lines. Other amenities may include benches, again, not required, but a nice amenity, lighting, routing and scheduling information, trash receptacles, bicycle parking. And just a reminder, I'm not sure we talked about this the other day when we talked about PROAG, but regarding the PROAG final rule that was issued in August of 2023, on December 18th of 2024, so what's that, about 4 months ago, the U.S., or 3 months ago, the U.S. DOT issued a final rule adopting PROAG as part of its ADA standards. And that final rule became effective January 17th of 2025. So most of PROAG, even though we have the final rule, most of PROAG is not enforceable because it's not been adopted by the DOT and DOJ, and they have to apparently adopt that, sort of together. But the part of PROAG dealing with transit, the US DOT does have, I'm not sure what the legal term is, but sort of unilateral authority to adopt that part of PROAG. So that part of PROAG has been adopted. And basically it says, as the last bullet indicates there, is new construction and alterations of transit stops in the public right-of-way will be there are any, and accessible connections to existing pedestrian circulation paths. And then, of course, bikes in transit, I kind of call this the first and last mile connections. We should try to make those connections seamless for users for long-term, short-term, and sheltered bike parking. Provision of or access to mobility sharing systems like bicycles, e-bikes, e-scooters, bike storage on transit vehicles. You can see the bike rack on the bus in the lower center, but also notice if an agency has, like in this case, light rail transit, notice how there's provisions for bike storage on the transit vehicles, the light rail vehicles. And then, of course, having adequate parking for bikes at bus stops, as illustrated in the lower left. So that's what I wanted to say about bikes. Now looking at maintenance, maintaining roads and streets for all users. This is a challenge for agencies, keeping facilities safe and accessible in terms of maintenance. Of course, federal funding not available for maintenance. Local agencies obviously are constrained in their resources for monitoring, inspecting, and maintaining pedestrian facilities. Many agencies have requirements that the property owner is responsible for maintaining the sidewalks on their property. Enforcement of this varies probably widely around the country, so that's kind of another challenge. And also, not only are there ADA consequences, meaning civil rights lawsuits if a sidewalk section is not accessible to those with disabilities, but if, for example, we have a heaved up sidewalk slab and an able-bodied pedestrian trips and falls at that location, there may be tort liability consequences where someone may file a personal injury lawsuit to seek compensation for their injuries or the harm that they sustained. So all of these things, I think, relate to inspection and maintenance of pedestrian facilities and do make it challenging for public agencies. And here are just a couple of the challenges. Notice on the left, the shrub has probably not been pruned or trimmed in a while, maybe years, and so it has overgrown the sidewalk, and now that's basically an inaccessible sidewalk. Able-bodied pedestrians can skirt around that, but someone with a mobility impairment or vision impairment, for them, this sidewalk would probably be inaccessible. And then on the right, we see, I mentioned the heaved up sidewalk slabs due to tree roots. Here's a kind of an extreme example of that. You can see a lot of old street trees along this particular street and sidewalk, and the roots are really doing serious uplifting of the slabs to the point where, again, that's an inaccessible sidewalk. I would also call it a potential trip and fall situation as well. So it's kind of a double whammy for the public agency. They could be exposed to civil rights lawsuits for ADA violations, but also if someone trips and falls, they could have a personal injury tort claim filed against the agency. And here's another maintenance challenge. And obviously not everyone in the country faces this, but certainly Ohio, West Virginia, other states in kind of the snow belt face this issue. And I took this, I was at the Transportation Research Board meeting in Washington, D.C. in January, and early in the conference, a snowstorm hit. I think there were like, 8 to 12 inches of snow. I thought that the city did a good job of clearing the streets. The property owners did a pretty good job of clearing sidewalks. But notice, and this was 3 or 4 days after the storm, but notice the connection here between the sidewalk and the street, and the crosswalk had been cleared at some point, but due to continued snowfall or continued plowing of the roads, those the windrows of snow accumulated again and made it very difficult, and I would argue inaccessible for someone with a mobility impairment to travel between the crosswalks and the sidewalk. So this is a challenge that probably relates to a lot of things, different jurisdictional issues, maybe equipment related issues, but I think this is a challenge that we need to kind of look at and try to address as we move forward. Of course, pedestrian facilities are part of the transportation system. That's what we're talking about during this entire 4-class session. And seemingly minor maintenance issues can discourage walking and form a significant barrier to people with disabilities. And it could be a elevation difference, or it could be a snow removal situation like I just showed in the previous slide. But those, what might seem to be minor maintenance issues, can prevent people from walking. And so I think maintenance of streets or roadways should automatically cover the maintenance of the pedestrian facilities, sidewalks, the curb ramps, crosswalk markings, ped signals, and other related features. And in fact, I may have mentioned this last week, but ADA requires that facilities be maintained. You can see Title II of ADA, there's the Code of Federal Regulation citation, states that state and local governments must maintain the accessible features of facilities in operable working condition. And public entities must maintain equipment and features of facilities that are required to provide ready access to individuals with disabilities. So in terms of maintenance, I think it's important to try to identify funding for maintenance before a project is implemented, and plan for preventive maintenance or maybe routine maintenance like vegetation trimming, or depending on where you are in the country, snow removal, ice removal in the winter time. Plan for periodic maintenance to deal with sidewalk cracking or crosswalk restriping or brick or pavers that have become buckled or heaved up need to plan for that type of maintenance as well. You know, and maybe that should be part of design, to try to come up with a design that reduces the need for maintenance, like maybe concrete slabs rather than brick or pavers. Even though the brick or pavers may be more aesthetically pleasing, there may be maintenance issues associated with those types of surfaces. And I just wanted to show some of the common sidewalk maintenance issues. Obviously, there's a wide variety of these, but things like surface defects, like spalling of the concrete, scaling of the surface, pop-outs, cracking. Here you see many of those illustrated. This sidewalk, in my opinion, is basically inaccessible. It'd be difficult, if not impossible, for someone in a wheelchair or using braces or crutches to navigate this section of sidewalk. Uplift or settlement of slabs, we've been talking about that. I'm not sure the tree roots are involved here, but notice on the left, clearly this slab has been raised up above the adjoining sidewalk. This becomes a change in level. Looks like it exceeds a 1/4 inch vertical, so that becomes a barrier to someone in a wheelchair, also a potential tripping issue for an able-bodied pedestrian. And one way to approach that is to sort of fix the underlying problem, or grind the higher surface like you see here on the right-hand side. A number of areas where they've done some grinding to kind of ramp the sidewalk down to the adjoining section. Another approach that could be used, depending on the situation, would be to put like a wedge of concrete to make that a beveled or ramp surface. I mentioned displacement of pavers. This is maybe not an accessibility issue here because it looks like there's sufficient relatively smooth surface that someone with an impairment could get around there, but I would contend that that's probably a tripping hazard there and a potential liability exposure due to that elevation differences. Settlement of surfaces. We see some ponding of water on a brick surface. Again, we could argue this is probably accessible. Someone can walk through there or use their wheelchair through there, but to me it's kind of more of a nuisance. Water in someone in a wheelchair, the water is going to be thrown up by the wheels and get on their clothing. Same thing maybe with an able-bodied pedestrian walking through there. And in wintertime, in cold climates, that may freeze when temperatures drop below freezing, and then we have an icy situation, which may create a safety issue. Number of examples of vertical discontinuities at utilities, utility covers. Some of these, for example, looks like the bottom center probably makes that sidewalk inaccessible. Others that may be maybe accessibility not so much an issue, but maybe safety in terms of tripping or slipping hazard created by the utility cover. Another common issue in some parts of the country, water flowing across walkways. We get algae growth in warm climates, or here it looks like some mud and silt has been carried across the sidewalk, or at least part of the sidewalk, and that presents a slip and fall issue. Likewise, loose materials on surfaces. Both of these are probably maybe due to anti-skid material that the agency was applying to the road in the wintertime for their snow fighting operations, but you can see that makes its way to the sidewalk, and especially on a grade or on a slope, those loose materials can really affect the stability of someone walking on those surfaces. I mentioned curb ramps there. They can experience a variety of maintenance issues, surface defects, damaged detectable warning surfaces like you see over here on the left-hand image. Notice the Edges are starting to curl up here, creating a potential tripping issue. Also, over time, some of these, depending on the product, some of these detectable warning surfaces may fade and lose the color contrast that they need with the background. And then this is interesting here on the right. Notice this agency is using the cast iron detectable warning surfaces, which are pretty durable, and it looks like they're holding up, but notice that the concrete is popping out and cracking around the detectable warning surface, so that creates some accessibility issues, also some potential trip issues as well. So the ADA features, in addition to the rest of the walkway, need to be checked for these sorts of issues or concerns. And then crosswalk markings. Here on the left, we see it looks like at one time this agency did mark this crosswalk, but I would say, to me, it needs to be renewed again, restriped with new paint. It appears they're using here, so that those, because the low vision pedestrians rely on the color contrast of the crosswalk marking versus the roadway surface to be able to navigate at crosswalks. And then on the right image, I hope none of you have this situation, but this is sort of a kinked crosswalk. Notice the crosswalk changes direction, essentially in the middle of the roadway. The bigger concern here is that this is a ADA communication violation, because the issue is, how does the blind pedestrian using the cane, how are they able to detect that change in direction? And of course, the answer is they are not. Paint is not detectable under a cane tip, and so a blind pedestrian really has no way of knowing that this crosswalk changes direction in the middle of the roadway. Then there's seasonal maintenance. I mentioned earlier, in some parts of the country, snow and ice issues, vegetation overgrowth, debris accumulation, these sorts of things kind of fall maybe into the routine or periodic maintenance category. And then things like clear width, especially in built-up areas, maybe in business districts. The walkway needs to remain free and clear of obstructions. ProAg requires 4 feet minimum. Some of you are aware it require 5 feet, but that needs to remain free and clear of both permanent and temporary obstructions. Notice on the left here, the pizza shop, I think they put this sign out every day and maybe take it in at night. But notice in its position here, it is essentially blocking the sidewalk. There may be 4 feet here, but it would be better maybe if it was moved closer to the street. And also, this design appears to be a protruding object issue. That this is, the sign panel is above cane detection height, and so someone may run into that before they detect it with the cane. So maybe a little bit different sign design, and maybe move it, in this case, maybe closer to the street, so there's a clear, unobstructed path for the mobility impaired and the vision impaired. And then this on the right, example of, I think, a phenomenon, of course, that's really taken off since COVID, the outdoor dining becoming very popular. And the restaurateurs are demanding maybe more and more sidewalk space, which is probably a good issue to have. But we still need to make sure that we have that 4-foot minimum clear, unobstructed width available for the PAR, the pedestrian access route. And vendors are nice. They're part of an active streetscape, but this, to me, is not an appropriate location for the street vendor. Looks like they're taking up the entire sidewalk. So I mentioned inspection. I think municipalities should develop and adopt sidewalk inspection and maintenance criteria that consider things like the displacement, the changes in level we talked about, changes in grade, cross slope, vertical clearance, the protruding object issue, maximum grades, minimum width, and those sorts of things. So those, to me, that's what should be included in inspections. And in terms of bicycle ways, they're also subject to surface deterioration. Pavements may crack, have other deficiencies. Debris may accumulate near the edge of the roadway, and so that can adversely affect bicycle safety. And so poorly maintained facilities may become unsafe or unusable for bicyclists, even though motor vehicles are able to travel without serious difficulty. Certain conditions may create safety and usability issues for bikes, and we'll look at some of those. Examples of some of the items to be inspecting are signals. Inspect push button responsiveness, the pedestrian signal indications, make sure they're functioning. Signs, check the sign face like you see here. It looks like this sign is not so visible anymore compared to when it was new. Are the signs still erect and properly oriented in terms of facing the user? Those sorts of things. A number of different inspection types. We could have a community-wide inspection, could be zone inspections, certain zones of the city, could be spot inspections, could be an inspection following a complaint or an injury incident, or it could be an inspection following a report by the public. Alterations, a term we hear used especially with accessibility. And alteration would be when we modify or reconstruct or rebuild something to change it from what it was or enhance it from what it was before. And so in ADA or in PROAG, there is a lot of interest in what constitutes an alteration. And different parts of ADA have different alterations that may trigger accessibility upgrades. But technically, maintenance activities do not trigger accessibility upgrades. But alterations which occur to pedestrian facilities or streets that impact pedestrian facilities are more significant probably than routine maintenance, and do offer opportunities to incorporate ADA compliant features. And when facilities are altered, the expectation is that the facility be accessible to the extent practicable to do so within the scope of the project. And here is some FHWA, Department of Justice guidance from back in 2013 that provides a little more care in terms of altering a street and the requirement to upgrade the curb ramps. And this came about as a result of a lawsuit in Philadelphia, Kinney versus Jerusalem, where the city of Philadelphia and the Pennsylvania DOT resurfaced streets in the city of Philadelphia, but did not upgrade the curb ramps or did not install ramps if there were none as part of that project, even though people were complaining about the lack of curb ramps or non-compliant curb ramps. And so for about the first, and that dates back to 1993, so for about 20 years, there wasn't clear guidance on what constitutes altering a street as part of a resurfacing operation. So in 2013, a committee of Federal Highway Administration and DOJ personnel came up with better guidance. And this is kind of a summary of that guidance. So you'll notice there's a heavy dashed line through the center of the slide here. If what you do to your road or street is an activity that falls above that line, it's considered maintenance and you don't have to touch the curb ramps. So for example, pavement patching. Probably any entity with roads probably does pothole patching or pavement patching. That's maintenance. Crack filling and sealing, I'd call that a pavement preservation technique. That's considered maintenance. You can see some other spot high friction surface treatments are considered maintenance. Chip seals are considered maintenance. Street sweeping would be maintenance. Painting lines on your roadway, lane lines, arrows, symbols in turn lanes, those are all maintenance. You don't have to worry about the curb ramps. But if what you do to your road or street is an activity that falls below that heavy dash line, then it's considered an alteration, and you do need to upgrade the curb ramp. So notice that adding a new layer of asphalt, doesn't matter how thick or thin it is, if you're adding a new layer of asphalt, that's considered an alteration, and as part of that project, the curb ramps need to be brought up to the current criteria. Likewise, mill and fill. Mill 2 inches of pavement off and put 2 inches back. You can argue you haven't really changed anything. If the elevations are still the same, you've just made it smoother for everybody, but that mill and fill is considered an alteration. And so as part of those projects, the curb ramps need to be brought in compliance with the current criteria. I mentioned bicycle facilities and the bike's susceptibility to what might appear to a motor vehicle to be kind of minor discontinuities. The bicycle may be adversely affected by those. So things like debris from the travel lane can accumulate maybe near the side of the road where people bicycle. The small rocks can deflect the wheel and cause a loss of control, or other debris, branches from a tree. Broken glass can puncture bicycle tires. So routine cleaning and clearing, as well as maybe more significant repairs and maintenance, are needed to keep bike facilities safe and comfortable year-round. As I say, what might be an adequate roadway surface for automobiles with 4 kind of relatively large tires, 4 or more, can actually cause difficulties for bicyclists with their narrow tires and much smaller contact area with the pavement. So things like longitudinal cracks and joints and seams from maybe resurfacing, these things can affect the control of a bicycle. Potholes can cause wheel rims to bend or tires to puncture, and can also be an issue. So what about some recommended maintenance for bicycle ways? One would be street sweeping. Establish regular sweeping schedule for roads and paths that anticipates both routine maintenance and maybe special sweeping needs. For example, maybe after a major rain event or storm event or something like that. Remove debris in curb sections with vehicles that pick up the debris. And think about another way to reduce the presence of like loose stone on the roadway pavement or the roadway shoulder is to maybe require paving of gravel driveway approaches like you see here. That just a few feet of hard surface there, asphalt surface, can go a long way in preventing stones and gravel from reaching the roadway itself. Some other recommended maintenance might deal with surface repairs. Inspect bikeways regularly for surface irregularities, keeping in mind that they'll be different and maybe more demanding than for a surface handling motor vehicle travel. Establish a process that enables agencies to respond to complaints in a timely manner, and prevent the edge of a surface repair from running longitudinally through a bike lane or shoulder to create that seam or joint that can adversely affect bicycle operation. Perform preventive maintenance periodically, keeping drains in operating condition. After a project, maybe has made some repair or something else to a roadway, sweep to make sure the loose material is removed from the travel way. And then think about a pavement preservation program for bike facilities that minimizes deterioration and cracking. Pavement overlays. Extend the overlay over the entire surface to avoid leaving an abrupt edge, that seam or edge within the riding area. Correct any edge of pavement drop-offs that may develop. During an overlay project, maintain the surface of inlet grates, I should say, and utility covers to within a 1/4 inch of the pavement surface. As I mentioned before, think about maybe paving back at least 10 feet on lower volume driveway connections, maybe 30 feet or to the right-of-way line on unpaved public road connections to try to reduce the amount of gravel or stone, loose stone that might spill into the bikeway. And then after overlay projects, again, sweep the roadway. Practices to avoid overuse of design minimums. It's not necessary to use the minimum widths for an entire street cross section. Think about rumble strip placement. We talked about this last week, how poorly placed rumble strips can make a shoulder basically useless for bicyclists or even create a safety issue for them. Another practice to avoid is not raising manholes or grates when you're doing resurfacing operations. And here's an example of what can happen. It looks like this roadway has been overlaid at least a couple times, maybe more. The grate was not brought up or there was no milling done. And so I would argue this is a safety concern for cyclists. Surface defects can be various types. But remember, bicycle tires are more demanding in terms of what the surface characteristics are than motor vehicle tires. Sediment or debris in the gutter, especially where the bicycles are turning, can be a safety issue. You see extensive kind of debris or leaves in the gutter there, creates issues for the cyclists. Pay attention to driveways. I mentioned that already, and here you can see it looks like a temporary driveway for a construction site, but notice you can see mud and stone and various materials are being carried or tracked out onto the road surface, creating an issue for two-wheeled users. I mentioned the overlays you see there on the left and the right, and the longitudinal seams and joints that can create real control issues for bicyclists. And then open grates. We should have bicycle-friendly grates, not grates like this. And see what happens, the front wheel of the bicycle drops into the grate opening, the bike stops suddenly and pitches the operator over the handlebars, usually face first, onto the pavement, so that the injuries here can be very severe and disfiguring. And then where appropriate, think about snow removal and ice control of the bicycle facilities so that they are usable year-round. But the interface, again, can be a challenge. I took this in Washington, D.C. I mentioned when I was there in January. And again, I mean, I think, you know, you can see the property owner cleared the sidewalk. The city did a good job with the street. They even cleared the bicycle lane here. But notice that interface. It looks like after they cleared the bike lane, the plow came through to maybe widen the roadway up a little bit. And now that's creating an issue for bicycle traffic. But this is a challenge. I'm not sure I have a good solution to that situation, but we need to be aware that that is a challenge and try to reduce the likelihood of situations like that.
Hey, Ron.
Yes.
Hi. So in the chat box under question 3, we had earlier comments from Michael, and then questions 4 through 7 appear to be related to alteration projects.
Okay. Let's see. Michael says, regarding road repurposing, road reconfiguration, road diets is a scary term to politicians. Yeah, I mean, I agree with that. That's why I'm mentioned that it's sometimes called road reconfiguration. It might not be as quite as scary a term. Or I mentioned somewhat facetiously, but the term road buffet might be a more positive sense of it, kind of improving, using various techniques to improve the roadway for all users, not only motor vehicles, but bicycles and pedestrians as well. And Ted asks, what about removing or upgrading signals? And that was probably relating to I'm not sure what I was covering at that time, but maybe related to transit or the interchanges. But no, I would agree with you, Ted. That probably should be another, or maybe for road diets, but that would be another thing to consider as part of the toolkit, if you will. So I would agree with that. And then Nicholas asks, during an alteration project, do adjacent sidewalks that are non-accessible need to be upgraded? For example, fixing trip hazards from upheaved sidewalks. Great question, Nicholas. And thanks for asking that. That's a question that comes up probably every time I talk about ADA and the Kinney versus Jerusalem case. And the short answer is no, you don't. The longer answer is, and probably this is maybe difficult for sort of engineers or other technical folk, planners to understand, but the basis for that, the guideline that we need to upgrade the curb ramps when we resurface a street was the Kinney versus Jerusalem court decision. And so it was a court decision. It wasn't sort of a engineering or planning kind of or policy document, if you will. It was a court decision. And so basically, when you resurface a street, what Kinney versus Jerusalem says, and FHWA and DOJ concur, is that you do need to upgrade the curb ramps at the intersection to bring them into compliance. But as Nicholas suggests, people ask, well, why do we have to upgrade the curb ramps if there's a big maple tree heaving up the sidewalk mid-block? People can't get from one intersection to the other. But if I have to do that too, if I have to do that as part of my resurfacing project, when will it end? I might have to rebuild every sidewalk in town. And so I follow that logic. But basically, Kinney versus Jerusalem and DOJ and FHWA say that when you do a resurfacing project or an alteration, you need to upgrade the curb ramps at the corners to bring them into compliance. You do not have to touch the sidewalk, say mid-block, but that obstacle, whether it's a heaved up sidewalk slab or whatever it is, maybe it's a big hole in the sidewalk that makes it inaccessible, that barrier, that obstacle needs to be on the agency's transition plan to demonstrate that they're aware of that barrier to mobility and they know what needs to be done to correct it. And of course, a transition plan also includes a schedule of when you're going to correct it. So that was a long answer, but I'd be glad to answer additional questions on that. And then Michael asks, as opposed to refreshing a previously existing crosswalk, is painting a new crosswalk an alteration that requires the ramps on either side of the crosswalk to be upgraded? Great question. That's one of the gray areas of ADA, of which there are many. But I would say, and this is Ron's opinion, I would say yes, if you're painting a new crosswalk or marking a crosswalk for the first time, I would say that it would probably be a good idea to make sure that the ramps on either side, either end of that crosswalk or both ends of that crosswalk comply with the current criteria. And then we have a follow-up from Nicholas, or just the curb ramps. Yeah, just the curb ramps. As part of the resurfacing project, just the curb ramps need to be upgraded. But remember, any barriers or obstacles between the curb ramps, or in the middle of the block, that sort of thing, those need to be or should be on your agency's transition plan to demonstrate that you're aware of those barriers. Good questions.
Thanks, Ron.
Thank you. Let's see, where were we? Well, with bikes, be sure to pay attention to surface condition. I mentioned that, but especially steel. And if you think about a typical street situation like you see here, notice we have an inlet grate here. We have manhole covers. If there's construction going on or utility work nearby, there may be steel plates. So if you think about it, there's a lot of steel oftentimes in our roadway environment, and especially wet steel, very slippery and can be an issue for bicyclists. I'm not sure where this is, but I kind of like this approach. Notice this is an open grate steel bridge, which, as you may be aware, when that steel gets wet, it's an issue for all users. I mean, motor vehicles, motorcycles, bicyclists, it becomes a slippery surface, and low friction is a concern. So notice this agency put in about a 4-foot wide strip here of concrete surface for bicyclists or motorcycles to use in negotiating the bridge. I mentioned before drainage grates. This doesn't look bike friendly, and it looks like it's in a curve sort of around the corner, not easy to see by a turning bicyclist. So this is not a good situation, in my opinion. Another place, of course, where steel is found in the roadway environment are at railroad highway grade crossings. And there's several issues in this regard. Number one is the crossing angle. How do bikes cross the tracks or the rails? What's the crossing surface condition, which of course at crossings sometimes can be rough or have other issues. And then a concern for not only bicyclists and motorcycles, but also for wheelchair users is the flangeway gap opening. So I'd like to look briefly at each of these. When a bicycle or a motorcycle, for that matter, crosses a railroad track that's skewed like this one is, it can create some serious control issues. So, and I'm starting to see more and more of this. I realize you can't always do it, but if it's possible, this is a good practice for reducing the effect of crossing angle on bicycles and create a safer crossing. So that's a good practice when you can do that. And as I said, I realize you can't always do that. Crossing surface deficiencies can be various types. For a timber crossing, it could be rotted and deteriorated timbers. There could be bolts sticking up. Could be a rough asphalt surface. But notice this is a concrete panel surface, which generally, is, in my experience, is a pretty good surface. But I don't know if you can see it here. For some reason, the railroad crew that did this did not butt the adjoining panels together tightly, and so there was a little gap there. And what happened, sadly, was, this is a recreation, not the actual event, but there was this is in Nebraska, a small town in Nebraska, one of these major kind of cross Nebraska bike event where hundreds or thousands of bicyclists ride across the state. And notice this particular bike tire dropped into the opening here, that very narrow opening where those panels were not butted up against one another. Of course, the bike stopped, the rider was pitched forward, struck the pavement, and actually, I guess, broke his neck, and he was fatally injured in this incident. And so this shows that small surface kind of deficiencies can have a major impact on bicycle operation and bicyclist safety. And then I mentioned the flangeway gap opening. What we're talking about is this opening right here. For freight railroads, it needs to be 3 inches. For light rail, I believe it needs to be 2 inches. But this is the flangeway gap opening. That's the opening that has to be there to allow the steel flange of the rail wheel to pass through the crossing, whether it's a road crossing or a sidewalk crossing. But I think you can also see how this could affect a bicycle, could affect a motorcycle, could also affect the small front wheels of the wheelchair. And just quickly, it's interesting, the first draft of PROAG, when it came out in 2002, said that at crossings like this, or I should say at sidewalk crossings, or where the PAR crossed the railroad track, there needed to be they called it a flangeway gap filler. And I guess the idea was that when no train was present, that gap would be filled with this filler material. And then when a train came through, the gap would compress or depress, whatever the word is, to allow passage of the train. And then after the train passed, it would revert to its original position to fill that opening. Well, the issue then and now is that, to my knowledge, no one has developed a good material or system that really works as a flangeway gap filler. So the current final rule of PROAG mentions the flangeway gap problem, but they don't require a flangeway gap filler, I think, in recognition of the fact that, to my knowledge, there is none that's practical at this point. So where your walkways cross and your bike lanes, as you see here, cross the tracks, be aware of that flangeway gap opening. That's why it's important if the bike can cross the tracks at right angles, that's what we should strive for. And I do see more and more of this being used, especially with light rail transit where there's street running in the street downtown. I like this warning sign. I think it satisfies the MUTCD requirements of warning sign, but also notice even the little detail of the bicyclist wearing a helmet. I like that sign. I think it's very effective in describing what the problem is. Bicycles in work zones, present some of the issues we've talked about already, the different surface conditions. Steel may be present, as you see here. Also, roadway space may be constrained. So bikes may be sharing, the roadway with motorized vehicles, or there may be pinch points we need to be aware of. Work zones should be compatible with bike travel. Notice a sudden change of elevation that you see here, or there may be construction equipment or materials in or near the roadway. A variety of different possible solutions. Have adequate advance warning and guide signs, good channelization and barricading to separate pedestrians and bikes from vehicular traffic. Warn bicyclists about surface irregularities. And pay attention to maintenance, as we've talked about. In addition to being safe, pedestrian work zones must be accessible and detectable. We don't have time to go into detail in that today, but Part 6 of the MUTCD and Chapter 3 of PROAG talk about the need for pedestrian work zones to be accessible and detectable. Notice this one on the right here, use of yellow caution tape. This is not a detectable work zone. Someone with a cane will walk into that work zone before this caution tape, kind of wraps around their chest. Also, there needs to be an alternate pedestrian access route around temporary sidewalk closures. There is none here. Similarly, it's hard to see the full picture here on the left, but the sidewalk on the other side of the street is closed. That's what this sign is trying to say, or it does say if you look at it from the right side of the image. But really, in that case, what should have been done here is there should have been some sort of barricade placed around the corner here to prevent pedestrians from even entering the street, since there's no sidewalk on the other side. But then I keep talking about safety and accessibility. Notice how there's these feet of the type 3 barricade kind of extends out into the curb ramp. That's a potential tripping hazard for pedestrians. So any questions up to this point?
Thanks, Ron. There are no additional questions at this time, but as a reminder to our audience, the questions box is available. Thanks.
Yes. Thanks, Mike. So that brings us to a discussion of the different types of bicycle facilities. And we'll start this today, and we'll finish up on Thursday in our last session. But before we get into the different types of bike facilities, I did want to mention that normally sidewalks are not considered a bicycle facility, since it's usually undesirable for bicyclists to ride on sidewalks where there are potential conflicts with pedestrians traveling at lower speed. Of course, pedestrians can shift their path in an instant, and so there's those potential conflicts. I'm aware there are locations where children may ride on the sidewalk, and that may probably not an issue. But generally, my point is, generally, sidewalks are not considered a bicycle facility. So I'm not going to mention them as part of the discussion today or tomorrow or on Thursday. Shared lanes, one type of bike facility. And of course, bicycles may be operated on all roadways except where they're prohibited by statute or regulation. So pretty much all roadways where bikes are permitted would be considered shared lane bicycle facilities. And of course, they exist in all contexts on streets and roads, urban, rural, suburban, variety of different situations. They're most appealing to bicyclists on lower volume, lower speed roadways and streets. Some research shows that the interested but concerned bicyclist category, if you remember that from day one of our discussion, they prefer not to operate in shared lanes unless traffic volumes are below about 3,000 vehicles per day and the operating speeds are at or below 25 miles per hour. If volumes or speeds get above those thresholds, the interested but concerned cyclists prefer separation from traffic, with a preference for physical separation where traffic volumes exceed about 6,000 vehicles per day or motor vehicle speeds exceed about 30 miles per hour. In terms of design features, there are no really bicycle-specific designs or dimensions for shared lanes or roadways. But various features that can make shared lanes more compatible with bicycling include, of course, as we've talked about, good pavement quality. That's important. Adequate sight distances, both over hill crests, for example, but also at intersections and driveways. Designs that encourage lower motor vehicle speeds and volumes, and bicycle compatible drainage grates, bridge expansion joints, and railroad crossings. So we've talked already about some of the things that make bicycling attractive in terms of like surface characteristics and sight distance. Those features then are also important on shared lanes. Another thing to think about is the shared lane markings, or the so-called sharrows. They may be installed within shared lanes, like you see in the photo here, to indicate to motorists and bicyclists where bicyclists are expected to be bicycling. By themselves, shared lane markings are not considered a bikeway because they do not change the geometric or operating conditions of the roadway to improve comfort and safety for bicyclists. Their impact on bicyclist lane positioning and motorist behavior on streets with higher operating speeds is moderate to negligible. But they can help reduce incidences of wrong-way bicycling. Shared lane markings are discussed in the Manual on Uniform Traffic Control Devices. They should not be used on roadways with speed limit above 35 miles per hour. And notice the manual says they shall not, a requirement, they shall not be used on shoulders or in designated bike lanes. And here's some guidance with respect to placement of the shared lane markings. For travel lanes less than 14 feet in width, it's preferable for the shared lane marking to be placed in the center of the lane to encourage bicyclists to control the lane. Where the shared lane markings are used with bikes may use the full lane signs, they should be located in the center of the travel lane. For lanes that are equal to or wider than 14 feet, the shared lane marking should be placed in the right-hand portion of the travel lane, a minimum of 4 feet from the face of curb, the gutter seam, or the edge of the traveled way. Where the lanes are 15 feet or more in width, it's preferable for a bicycle lane to be provided in place of a wide outside lane. And on streets with parallel on-street parking, preferable to place the shared lane markings in the middle of the lane. We'll talk more about this dooring issue next time, but there was a question about what can we do to, I think, minimize that issue. And one way here is where you do have streets with parallel on-street parking, place the sharrows in the middle of the lane. I mentioned the bicycles may use full lane sign. This can be used in situations where motorists must either change lanes in order to pass a bicycle at a safe distance or operate at reduced speed behind the bicyclist until there's an opportunity for safe passing. So that was the shared lane facility and the shared lane markings. Another type of bicycle facility, I'll mention it, although it's not really recommended anymore, I don't think, are the wide outside lanes. It used to be in the past in some jurisdictions to provide a minimum of a 14-foot wide outside lane. So you can see where my cursor is here. So notice the motor vehicle and the bicyclists, they are operating in that 14-foot wide lane, or wider, maybe wider than 14 feet. But experience and research show that this really doesn't adequately provide safe passing distance. And motorists generally do not recognize that this additional space is intended for bicyclists. I'm aware of one city, for example, I think they used a 15 or maybe even a 16-foot wide outside lane near a university campus. And I'm not sure they had bicycle incidents, but what ended up happening is that the motorists tried to make that outside lane 2 lanes rather than 1. And so that created some operational issues and I think some sideswipe incidents and that sort of thing. So that was to me a negative impact of the wide outside lanes. So as I say in the last bullet, the current thinking is the wide curb lanes are not recommended as a strategy to accommodate bicycling. And as I think I mentioned just on a previous slide a few minutes ago, if you have lanes 15 feet or wider, it's probably preferable to install a bike lane rather than the wide lane concept. And that brings us to the end. We're maybe a couple minutes early here, but I'll be glad to answer any questions anyone has. Next time on Thursday, we'll look at a variety of other types of bicycle facilities. I mentioned we'll talk about colored pavements, which I discussed today, talk about some other bicycle considerations, and then we will wrap up discussing shared use paths with a case study example. So Mike, before I turn it back to you, I'll just see if there's any questions and thank everybody for coming today and for your great questions, and we will see you on Thursday. Mike, I'll turn it back to you.
Thanks, Ron. Yeah, we do have a few minutes available if there are any additional questions. So within the next 24 hours, our LTAP office will send out a follow-up email with a link to the video recording from today's webinar. And then, as Ron mentioned, on Thursday, we will have day 4 of this 4-part webinar series. So we look forward to seeing everybody then on Thursday morning. Ron, I do not see any additional questions at this time. So thanks again so much for presenting today. We appreciate it.
Yeah, you're welcome. Just one more comment before we close. I'm going to let everybody go. I think last week we had a question or 2 or 3 about the so-called directional indicators to kind of separate the visually impaired pedestrian from, say, bicycle facilities. That is on our agenda. We will talk about that on Thursday as well.
All right. Thanks, Ron, and thanks, everybody. Have a good day.
Thanks, everyone.